Hello, everyone. We're going to go ahead and go over section 11.2, which is on picturing data. So as an overview, now that we've gathered some data, we want to effectively present this data. We've learned how to make frequency distributions and stem and leaf plots, but they're not very eye-catching. And this is where graphical representations are going to come in. So if we look to this picture here, we have identity theft climbing. A very, cartoony picture here, but we do see that the trends in this graph are going to increase over time. The time being in years by complaints in the thousands. So we see identity theft is growing throughout the years and whatnot. And so we have the graph here. We can definitely tell that just by looking at the graph. We can see it's kind of waves, but we see there's definitely an upward trend. We got that information just by looking at it very quickly and determining that almost right off the bat. At the bottom, we have the table of year and complaints. So we see the year and we see the corresponding number of complaints in thousands. And so while we get the same information from the original kind of table graph here, it was much better representative in the graphical representation instead. So while I can deduce the information from the table, the graph was just a better image to look at and get the effect of the data that I'm trying to share. So starting off with the first example, what type of graphical representation is this? We have a picture here. We have Amount of Love according to bands. So the Beatles, All You Need, Led Zeppelin, Whole Lotta, The Doors, 2 times, Bob Marley, 1, you fill in the blank. So we're comparing, in this case, amounts of love based on different bands. So we've gone over different graphical representations in the past, but just to kind of review here, this is a bar graph. We have different categories and the amounts, which are, a little fuzzy in this case, but the amounts are listed and they're separated by their different categories, which is the different bands. Then what type of graphical representation is this? There are two types of people. In blue, we have people who hate the sound of their own voice. And in this orange color, we have Morgan Freeman. So in this case, we have a pie chart. There is a pie here. There is a little sliver taken out just for Morgan Freeman there. But that is a pie chart. Then we have what type of graphical representation is this? Dogs versus cats, how much they miss you relative to the time you're gone. So dogs, it's very quickly, who are you? Oh, it's you again. Oh my gosh, I thought you were dead. And it's pretty much like that after about 5 minutes. So anytime you're gone longer than 5 minutes, they are so scared that you left them forever. And cats, no matter how long you're gone, it's always just, who are you? So in this case, this would be a time series graph. We have a time that is listed, and then we have different kind of results based on those times. Then this one here, it is very similar to a bar graph, saying health. It's very similar to a bar graph. It is a little bit different in the sense that there are numbers along the x-axis and there are numbers along the y-axis. Along the x-axis as well, they are negative and positive, while the y-axis is only positive. This is called a histogram. A histogram is similar to a bar graph, but instead of being broken up by categories, it's broken up by values, by other values. Then we have, a frequency polygon. The answer came up pretty quick here. A frequency polygon is just a drawing that is layered on top of a histogram. So in this case, all the bars here are representative of the histogram. The frequency polygon is drawn on top of the bars of the histogram to kind of give a general shape of the data. And it's connected in the midpoint of each one of those bars there. So just a little review of what's to come. So we have bar graphs and pie charts in this case. So when data is representative of certain categories, we use a bar graph or a pie chart also known as circle graphs, to illustrate that data. So whenever you have categorized data, that's when you want to use a bar graph or a pie chart. So starting with the pie chart is a circle divided into sections to represent the relationship of the parts to the whole. So to find the number of degrees corresponding to each slice, we need to use the following formula. We say that each slice of our pie is representative of a percentage of the whole, which is 100%. So each part of our pie should be divided up percentage-wise. And percentage-wise, typically we tend to use degrees. So we have degrees would be equal to the frequency of the specified class divided by the sum of all the frequencies. And then we take that number and multiply it by 360 degrees. So essentially, we're still kind of using a percentage thing here, except we're just expressing it in degrees. So every 90 degrees is representative of a quarter. So we can kind of use that mentality when drawing out our circle. Then when a pie chart is used to compare parts to a whole, a bar graph is used more to compare parts to other parts. So a bar graph doesn't necessarily really care about the whole, it's just comparing the parts to each other. The pie chart has to compare the parts to the whole, so it does matter in that case. Bar graphs are really good to use when categories overlap, which is an example of when you can't even use a pie chart. You can't use a pie chart if categories overlap because with the pie chart, it's very distinct percentages. It's very distinct slices of the pie. So you can't have anything overlapping in that case because then it would be parts of multiple slices and that won't happen. So bar graphs can be used if you have any overlapping categories. We have some pictures of bar graphs and pie charts. So in this picture, we have shoes on people and on dogs. So on people, it's like, normal. On dogs, though, very cool, very cool. Then we have, are you colorblind? There's a pie chart. No, no, but in red. When it's obviously in yellow, so still no. So as an example of a bar graph and a pie chart. So our example we're going to do together, we say the Harris poll asked 2022 adult Americans if they have a household budget and if they stick to it. The results are summarized below, so we're going to put the data in a pie chart and a bar graph. So we have our responses and their frequencies. So 687 people said that they have a budget and they stick to it. 789 people say they have a budget but they don't stick to it. And 546 people say they don't have a budget in general. So we're going to take this information and we're going to rewrite it into a bar graph and a pie chart. All right. So here we are with our example. Now I have to do both the pie chart and the bar graph. So we're going to have to do them separately. Let's just go ahead and start with the bar graph. Should be a little bit easier. We don't really need to convert anything into percentages. So when we have a bar graph, one thing that's important to do is that we need to have the right amount of values along the y-axis and the right categories along the x-axis. So if we look at our frequencies here, we kind of range between 500 and almost 800. So on our frequencies, we want to make sure that we have the right amounts. So since it's almost 800, maybe we go by 200s and go up to 800. So we can draw our bar graph here. So we have our graph here. And we can color code the different options. We want to make sure to label our y-axis though. So let's go 200, 400, 600, 800, and then we'll put smaller notches for the 100s. So we have 200, 400, 600, 800. So now we can set up our different bars. So for the first one, we say we have a budget and we stick to it. So we're going to need to kind of label that. So we can go ahead and make little notches in here. So that'll be the first one. We could say have one, sticks. So that's the first category. Have a budget, sticks to it. And so that frequency is 687. So it's going to be pretty much just shy of 700. So we want to draw our bar graph. So it's going to go up to almost 600. both sides here. And we'll connect it. And there's our first bar. We can color it in a little bit. So there's have one and sticks to it. So have a budget, sticks to it. And I can pick a different color and do have a budget and doesn't stick to it. So this one will be blue. So this is have one, doesn't stick. And this is 789. So it's just shy of 800. So this one is going to be taller in this case, just shy of 800. There we go. And same thing, we're going to color this one in too. Then for our last one, we have that we don't have a budget at all. That one will be in green. So don't have a budget at all is 546. So pretty much a little less than 600, halfway, probably between 500 and 600. So for this last one, we're probably going to go to about right here-ish, maybe a little bit taller, like there. A little slanted, but it's okay. It's still accurate. And this one was don't have one. And there we go. So with a bar graph, we're more so just looking at categorizing each thing and then making sure we get up to the value that is represented. So even though we were told the amounts and we were given the values from the beginning, we could very quickly just look at this graph and go, oh, most people have one and it doesn't stick. Or most people have a budget and they don't stick to it. And we can say that just by looking at the graph, the tallest one is the most frequent, and so that's the most common result. So there we go. There's the bar graph. Bar graph. So now we can go ahead and work on the pie chart. The pie chart will be a little bit different just because we have to convert into degrees. When we make a pie chart, we want to make sure that our pie chart is expressed in degrees. Sometimes it's also in percentages, but for us, we're going to do it in degrees. And so when we convert to degrees, we have to take every category and convert it. So we said that that was done using the formula that we saw on that last slide, where it was degree was going to be equal to the amount frequency of that option divided by the number of the whole and then times 360 degrees. So you go ahead and start working on that. So our first degree one here, we have our first response. We'll even number these just to kind of keep track. So starting with number 1, converting to degrees, we have our frequency of our option, 687, and we're going to divide that by the whole. So that value gets multiplied by 360 degrees to give us our degree value. In this case, we're just going around to 1 decimal place. And so taking 687 and dividing by 2022, we should end up getting 122.3 degrees. So having a budget and sticking to it would be about 122.3 degrees. We know that 1/4 is 90 degrees, and then 1/2 in that case would be 180 degrees. So this amount will be somewhere between 1/4 and 1/2, probably close to about halfway. All right. So now for the second one, where we have a budget and we don't stick to it. So now we have the number 789 and dividing that by the whole. Then multiplying by 360 degrees. So putting that and doing that in our calculators, we should end up getting 140.5 degrees. So 140, that's definitely pretty close, closer than the 122.3 degrees to 180. So our second option will be closer to a half, but still not quite half. Then we have our third, where we don't have a budget at all. So 546 over 2022 times 360 degrees. So we multiply those together and rounding to the first decimal place, we get 97.2 degrees. So we have now converted all of our values into degrees of our pi, or degrees of our circle. So now we can go ahead and try to draw out our pie graph, or a pie chart. Let's draw a circle. There we go. So starting with our first category, you can really start with any category you like. So looking at it, actually starting with the biggest category is probably going to be the best. So let's start with number 2, which was 140.5 degrees. So if we consider a quarter being 90 degrees, a half would be 180 degrees. So this is definitely between a quarter and a half. Half of the quarter would be 45 degrees. So what we can do is we can add 45 degrees to 90, and that would make 135 degrees would be a quarter and about an eighth, half of a quarter. So that's fairly close to our 140.5 degrees. So we can kind of stick with that. Another thing we can do to kind of help us a little bit here is we can try to divide up our pie a little bit. If we divide our pie into 4, so we know that this would each be a 90-degree segment. So if this is each a 90-degree segment, and this here would be a 45-degree segment, what we can do is that 90 plus 45 is 135. Our second category there is 140.5 degrees. So we can go ahead, wrong color, and draw over these parts here. And it's just going to be a tiny bit more than the 135 degrees. So there we go. So we have this category. This is have one, doesn't stick. So we'll kind of color around that a little bit. So that's our percentage of our pie. We can erase these values. So our pie, in this case, which we said was our 140.5 degrees on there, we have our representation. Now we want to do whatever is next, whatever's going to be easiest. Looking at our values, we've already kind of checked off our second one here. So we have 1 and 3, which are left. 1 is 122.3 degrees, might be a little harder to represent in this case. And number 3 is 97.2 degrees. 97.2 degrees is only a little bit more than 90, and we still have a quarter left in our picture. So it might even be easiest to go on to number 3 and leave number 1 for last. You can always draw it out however way that you want, especially if you can imagine it right off the bat and you can just go in order. That is fabulous, but really it's just whatever order that you like. Typically, I start with the biggest one And then I go with whatever's just easiest next, maybe whatever's most similar to a quarter or a half. So that's something that you can always have as an option. Since number 3 is closest to a quarter, let's go with the quarter. So pull up that green color here. And so 97.2 degrees is a little bit more than a quarter. So we know that it'll start around here, and it's going to be just a little bit more than the quarter. So there we go. We gotta erase the marks that we made. We can erase all of them at this point because we know that what's left is going to be the first category. And so our green category here, we said doesn't have one at all, doesn't have a budget. And we can kind of color in what was left over. And the third category was 97.2 degrees. Then we have our last category. It's the last slice of the pie. So we're just going to fill it in. This was have a budget and sticks to one. We do our best to draw it in here. This was have one, sticks to it more specifically, but you get the picture. And this one was 122.3 degrees. So there's our pie chart. So usually when it comes to pie charts, the most difficult thing is converting things into degrees and then making sure that whatever you draw is representative of the image. Especially whenever you are hand drawing things, you are just going for, does it look accurate? It doesn't need to be perfect when you're hand drawing, but it does need to be accurate. So in this case, we have it looking pretty accurate. Our third category there was a little bit more than the quarter. Our second category there was somewhere between a quarter and a half. And then our 122.3 degrees filled in the rest. So, all right, that wraps up this example. Let's go on and go back over to our lecture. All right, so we just looked at pie charts and bar graphs. Now we're going to look at histograms and frequency polygons. So when data is organized into grouped frequency distributions, two types of graphs are used to represent them typically: histograms and frequency polygons. A histogram is very similar to a bar graph, the only difference being that the class limits are placed on the horizontal axis instead of categories. So instead of having those categories like how we saw before, where we had a budget and we stick to it, and we have a budget when we don't stick to it, or we don't have a budget, those are descriptive categories. Histograms are more so used with numerical categories. So class limits, having a certain, kind of diagram and separating that out by values that are representative of classes. So that's when a histogram is used more often instead of a bar graph. So bar graph is always good for descriptive categories. Histograms are used for the numerical categories, which are AKA class limits. Then we have a frequency polygon is very similar to a histogram, but instead of bars, a series of line segments are drawn connecting the midpoints of the classes. Frequency polygons are very often just drawn directly over histograms. So in this case, where we have our two pictures here, these are representative of the exact same situations here. So we have our histogram, and this is our polygon that would have been layered essentially right on top. So it starts at 97, being between the very first time points that we have here. So it started at 97, and then it goes to the midpoint of 100 to 105. Since 100 to 105, the midpoint is technically 102.5. They just went with 102 in this case. And then that's kind of how they stuck with the midpoint going throughout. And so your frequency polygon, like how we're going to draw it, we're just going to label it right on top of the histogram, because that's essentially how we end up drawing them in the first place. We draw them on top of histograms to end up getting the midpoints. So for example, we're going to draw a histogram and a frequency polygon for the following frequency distribution: which represents the number of losses by the team that won the NCAA men's basketball championship for the years 1939 to 2016. So we see here in the picture, we have losses and we have the frequencies according to those losses. So from 0 to 1 losses, that was a frequency of 13. From 2 to 3, it was 28, 45, 21, 6 to 7, 9, 8 to 9, 4, and 10 to 11, 3. So we're going to go ahead. We're going to draw our histogram and our frequency polygon. All right, so considering our losses and their frequencies, we want to make sure when we draw our histogram that we need to have enough values that can take the frequencies and then enough values that can also take in the number of losses. So for example, our highest frequency is 28. So we want to make sure that we have at least 28 places to kind of notch on our y-axis. While on the losses, we have max of 11. So we want to make sure we can have at least 11 on our x-axis, because this is the x-axis and the y-axis. So we can go ahead and start. So we can draw our y-axis and then our x-axis from there. So in this case, we've got the frequency, and the number of losses. So we want to make sure to label everything correctly. So for us, the highest number is 28. A good number to pick is 30. It's kind of a nice, even number divisible by 5s. So we can kind of go by 5s and make the tallest one 30. So our top option here will be 30. So we can go down the row here at the midpoint. It should be 15. So we'll have 5, 10, 15, and then 20, 25. So each one of these notches is going to go by 5s. Then we have our losses. So we have 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11. If we notice something here, there's no information from 1 to 2 or 3 to 4 or 5 to 6 or 7 to 8 or 9 to 10. We only have 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11. So because of that, we're going to write out our numerical kind of class limits and then just call it there. Because with histograms, what's very happens most often is that the bars of the histogram will be touching. Well, bar graphs, they don't always have to touch. They can, but they don't typically also. So that's also a telltale sign between histograms versus bar graphs. Histograms, the bars usually touch. Bar graphs, they usually don't. So on our losses, we'll make a notch here, and this will be 0 to 1, 1 to 2, 3 to 4, 5 to 6. Oh, these ones. Yep, see, I did it already. We've got 0 to 1, and then 2 to 3, 4 to 5, 6 to 7, 8 to 9, and 10 to 11. Over here, in this case, we would just have 12 plus. So we can go ahead and start putting up our data. So our losses for 0 to 1, the frequency would be 13. So on the first part here, between 0 and 1, we want to make sure that it goes to about 13. So we have a 15 notch. We're just going to make it probably a little bit more than halfway between the 10 and 15 notch. So I'd probably be right like around here in this case. Draw. Let's make that better. All right. Pixel. There we go. All right, so the very first one looks kind of like this. Color it in a little bit. It's always nice to color in a bit. So once again, this is 10, and then 20. And the one at the bottom is 0, 25. All right. Our next one, 2 to 3 is 28. So this is the one that almost reaches 30. So it's definitely going to be quite tall here. So definitely going to be the tallest one. That was nowhere near that line. maybe a little longer, maybe about right there. So we have this graph here. It's almost at 30, but it's not quite at 30. And then we have, here we go. It won't be perfect, but we'll make it accurate. All right, so for 2 to 3 should be probably around there. Then we have for 4 to 5, it's gonna be 21. So this is just slightly above 20. So maybe right about here. Maybe without it curving up too much. Probably about there. A little bit more than 20. Then we have 6 to 7, it's 9, so a little less than 10. So now we're really going to kind of take like a dip here. And then we have 8 to 9 is 4, so even less than 5. And the last one is 3, so just a little bit less than the one before. And so there would be our histogram. So we have the number of losses there along the x-axis, so our class limits, and then we have its frequency along the y-axis. So this is our histogram here. So we'll say histogram down here, histogram. And then we're going to add on our frequency polygon. We said the frequency polygon is based on the midpoints of each bar in the histogram. So what we can do is that on each one of our bars, we're going to put a little red dot on each one at the top in the middle. We're going to put one at our starting point, which is 0. And then we're going to put one kind of in the next kind of ending there, like a 12. So what we can do is now we're going to connect our dots in order. So from 0 to the very first one, then we have the first one to the second, second to the third, third to the fourth, fourth to the fifth, fifth to the sixth, and then we have the last one. So that would be how you draw a frequency polygon. So the frequency polygon is usually very dependent on the histogram because it's really easy to draw one once you already have a histogram. But if you don't have a histogram yet, it might be a little hard. So we have the frequency polygon there in that case. So we have accurately described the situation that we were given in this case. So, all right, let's go on ahead and go back on over to the lecture. All right, then our last one here we have is a time series graph. A time series graph can be drawn for data that has been collected over a period of time. So this graph is primarily used to show trends like rising prices for specific time periods. So if we look over here at this picture, we have violent crimes per 100,000 citizens, and we have the year. So each one of these plot points were given probably by a table where we were told how many there were at specific times of year or specific years. And so what we would do is we would plot all of those plot points, and then at the end we would connect them in a line. It's almost similar to how we did the frequency polygon where we connected the midpoints of each bar. This one is just different. It's a time series graph, so it has to do with time, where a frequency polygon does not have to do with time. So the time series graph is specifically time versus amounts of things or whatever you're analyzing. It's always time. So there are 3 types of trends. The first one is secular trends, which are viewed over long periods of time. So data that has been collected over a very long period of time, that is typically what we call secular trends. Then we have cyclical trends. These will show oscillating patterns. Something cyclical would be like the temperatures throughout the years. So temperature throughout the year, typically It's going to be hotter in the warmer months or middle months, and then it's going to be cooler in kind of the winter, fall months in there, and then it'll kind of go back and then up and down and up and down and up and down throughout the years. Because typically weather goes up and down based on, kind of our placement on the earth and how it rotates and whatnot. So that would be a cyclical trend, something that is oscillating. Then we have seasonal trends, which are viewed over shorter periods of times like seasons. So a cyclical trend would be like temperature over the years. Seasonal trends would be something like temperature in the fall, temperature in the winter, temperature in the spring, temperature in the summer. So it's smaller periods of time. It's very typically like seasonal, although it doesn't have to be the seasons of the year. It can just be portions of the year or any portion of time. So secular trends are trends that are over very long periods of time. Doesn't really matter how the data is acting. Cyclical trends are oscillating patterns. The time frame necessarily doesn't really matter. Then seasonal trends are usually data viewed over shorter periods of times, like seasons, although they technically don't really have anything to do with seasons. It's just trends over shorter periods of time. So those are three different types of trends that we can kind of see in the time series graph. But either way you look at it, typically what you do is you plot the amount versus its specific time and connect the dots. And then you have a very clear graph on whether things were increasing or decreasing over time. So for example, we have the number of bankruptcy filings in millions in the United States for even numbered years from 2002 to 2016 is shown in the following table. We're going to draw a time series graph for this data. So we have the years from 2002 to 2016, and it's even years, so we're skipping any odd years. And then we have the number of filings, which are in millions. So we have 1.58 in 2002, 1.60 in 2004, 0.62 in 2006, 1.12 in 2008, 1.50 in 2010, 1.22 in 2012, 0.94 in 2014, and 0.79 in 2016. So we can go ahead and use our data to try to draw our time series graph. So let's go ahead and do that now. All right. So for our example here, we have a certain number of years. It looks like we've got about 8 years here, and then we have 8 corresponding filings. Our years are going by 2, starting at 2002 to 2016, and then our filings are in decimal values. All of them are less than 2. The lowest one here is 0.62 in this case, but our highest one is 1.60. So they're decimal values, they're fairly close together. We want to make sure that we have the right numbers on here. So let's go ahead. We're gonna draw this one a little bit bigger since we kind of have, a little bit more room to work. So we have our time series graph. We've got time on the x-axis and the filings on the y-axis. So these are the filings, and this is our year. So we want to make sure that we're going between the years of 2002 and 2016. If we want to make sure that all of our information is in there and kind of, accurate and nice looking, maybe we start this at 2000 and end it at 2018. So we can begin at 2000. We'll make that kind of like the 0 on the graph. So we want to have these by 2s, so 2002, 2004, 2006, 2008, 2010, 2012, 2014, 2016, we fit on there, but we want to make it just a little bit longer. We want to include 2018 on here as well, just to kind of keep the graph all contained. Then we want to focus on the y-axis. So since we're only going up to 1.6 and our lowest value is 0.62, and in decimals, we can go by quarters. So we can go by 0.25s. So the base of our y-axis is essentially 0 in this case. So we can put a 0 there. And then we're going to go by the 0.25s. 0.5, 0.75, and here we have 1. 1.25, 1.5, 1.75. All right, so we've essentially fit everything on here. So now we want to plot our points. So in 2002, we have 1.58, so just a little bit more than 1.5. So 2002, maybe it's going to be right around here, just a little more than 1.5. And then 2004, we have 1.6. So it's going to be very close, but it's just going to be just a hair more. So in 2004, it's just going to be just slightly above, probably just like that. Then in 2006, we dip down to our lowest value, 0.62. So in this case, this will be probably about halfway between 0.5 and 0.75. So probably right around here. Then in 2008, we have 1.12, so probably between 1 and 1.25. So right around here. Then we have 1.5 exactly in 2010, so we want to make sure to try to line that one up as best as we can. Probably right around there. Then we have 1.22 in 2012, so just below 1.25 in 2012. Then we have 0.94, so just a little under 1 in 2014. And lastly, 0.79, so just a hair above 0.75 in 2016. And that contains all of our data points. Our data starts in 2000 and ends in 2018, just to kind of keep it contained and show where it starts and ends. But by all means, you definitely could have started at 22 or 2002 and ended in 2016. There we go. So you definitely could have done that as well. As long as you get your data correct, there's really not a whole lot of specifics about the time series graph and like specifics about how you draw it, where you start it, all that kind of information. It's always good to have all the information on there. It's good to always have the data that you need to. Just make sure that it fits in there in some way. So now that we have all of our points, we're going to connect them. Since this time series graph, we start in the earliest time and we go to our latest time and connect in order. So connecting from 2002 to 2004, 2004 to 2006, 2006 to 2008, 2008 to 2010, 2010 to 2012, 2012 to 2014, and 2014 to 2016. So in this case, we do kind of see here, there was definitely a little bit of a linear pattern, maybe in this case. But there we go. So we've connected up our points as best as we can. We kind of showed our time series graph. So by looking at the graph, we get, the really good idea that it started kind of high, made a really strong dip, and then gained again. And then this has kind of slowly been decreasing since then. So it was our last example. Let's go on over back to the lecture. And that wraps up our section 11.2. So in 11.2, we learned how to draw bar graphs and pie charts, histograms, and frequency polygons, and time series graphs. So, all right, if you have any questions, always feel free to email me, and I'll see you in the next one.